One analyzes the diagram to see if L is parallel to M. His teacher asks if there's enough information to say whether the lines are parallel. One says yes. If a transversal intersects two parallel lines, then the alternate interior angles are congruent and the corresponding angles are congruent. Since he has both relationships there must be parallel. So, what we learned last time is we were given parallel lines. And if we're given parallel lines, then the alternate interior angles are congruent, corresponding angles are congruent, alternate exterior angles are congruent, and the same side interior angles are supplementary. Okay? What we're going to now is just the opposite of that. If we know that corresponding angles are congruent, or alternate interior angles are congruent, or alternate exterior angles are congruent, then the lines have to be parallel. Okay, if we know that in advance, then the lines have to be parallel. So, if lines aren't parallel, are corresponding angles, this is to the upper right and this is to the upper right, are they going to be congruent? Are these two angles here and here the same size? No, you can visually see that. So, corresponding angles are never going to be congruent if the lines aren't parallel. They have to be congruent. So we have various theorems that are called the converse of whatever theorem. Okay. The first one's the converse of the corresponding angles theorem, which says if the corresponding angles are congruent, then the lines are parallel. Okay. Before, when we had the corresponding angles theorem, it said if the corresponding angles are, or if the lines are parallel, then the corresponding angles are congruent. Now it's just backwards. If we have corresponding angles congruent, that makes the lines parallel. The converse to the alternate interior angles theorem is if the alternate interior angles are congruent, then the lines are parallel. So this would be parallel to this if the alternate interior angles are congruent. Now, they introduced the concept of a flow proof. A flow proof uses arrows instead of using, columns or a paragraph. It uses arrows to do the proof. So we are given that angle 1 is congruent to angle 2. The alternate interior angles are congruent. We're supposed to prove the converse of the alternate interior angles are congruent. So first we say angle 1, after we say given angle 1 is congruent to angle 2, then the vertical angles are congruent 1 and 3. And using substitution of the transitive property, we replace angle 1 here with angle 2 up here. So 2 and 3 are congruent, and we know the lines are parallel because of the converse of the corresponding angles theorem. So that's a flow proof. It just uses arrows instead. Okay, same side interior angles. We haven't talked about that yet. Same side interior angles, if they are supplementary, then the lines are parallel. Okay? So if the alternate interior are congruent, alternate exterior are congruent, or corresponding are congruent, then the lines are parallel. If the same side interior angles are supplementary, then it makes the lines parallel to each other. And that's the alternate exterior angles. Okay? So, which theorem says that these lines are parallel because angle 3 is congruent to angle 7? What types of angles are 3 and 7? Corresponding. So it's the converse of the corresponding angles theorem. What about 3 and 6? If 3 and 6 are congruent, what tells us that these are parallel? What types of angles are 3 and 6? Alternate interior angles. Okay? Couple other theorems that we have is if B is parallel to C and A is parallel to C, since they're both parallel to the same line, then A and B have to be parallel to each other. Two lines that are parallel to the same line are going to be parallel to each other. And two lines that are perpendicular to the same line, A is perpendicular to C and B is perpendicular to C, that makes A parallel to B Because if they're both perpendicular to C, they have to be parallel to each other. So when building a gate, how does Bailey know that the vertical board V and W, this board and this board, how does she know that they're parallel to each other? Well, we have a right angle here and a right angle here. So that's right up here. W is perpendicular to A and V is perpendicular A. Two lines that are perpendicular to the same line are parallel to each other. Okay, so that's what we're learning in the first lesson. Okay, so it won't take you too long to do in 20 minutes. We're going to start on the second.